Kiplagat, a grade 9 student from St. Benedict School of Peace Arrow. Today I'm going to take you through mixtures, elements, and compounds. Under that, I will go through structure of an atom. Let me firstly start with the definition of the terms mixtures. Mixtures is a combination of two or more elements. There are two types of mixtures: heterogeneous and homogeneous. Homogeneous mixture is a mixture that is uniformly distributed, and heterogeneous mixture is a mixture that is not uniformly distributed. An element is a pure substance that cannot be broken down into simpler substances by any chemical means. Some examples of elements are hydrogen, helium, carbon, potassium, calcium. A compound is a pure substance that is made up of two or more elements that are chemically combined. For example, water, the elements that make up water is hydrogen and oxygen. Carbon dioxide is carbon and oxygen. So we are going through structure of an atom. Let me first start to define the term atom. An atom is the smallest particle of an element that can take place in chemical reaction. In an atom, there are three subatomic particles, that is electrons, neutrons, and protons. Protons are positively charged, neutrons are neutrally charged, and electrons are negatively charged. So let me draw a structure of an atom and then this is the nucleus that contains protons and neutrons. This is the energy level. This contains the electrons. Let's go to the atomic number and the mass number. Atomic number is the number of protons in an atom, and whereas the mass number is the sum of protons and neutrons of an atom. For example, sodium has atomic number of 11 and a mass number of 23, where we can do the mass number of sodium mass number is equals to the sum of protons and neutrons. So we can do, for example, for sodium has 11 protons and 12 neutrons. So it has a mass number of 23. And it can be represented by a chemical symbol, where you use the symbol for example, for sodium, the symbol is Na, and you will write their atomic number as the subscript and the mass number as the superscript. You can represent an element like this. We are also going to electronic configuration. An electronic configuration can be shown using crosses or dots. This is the number. It shows the electrons found in an atom. For example, the electronic configuration we'll use the same sodium. It has 11 protons, and the electronic configurations, the energy levels of the electronic configurations accommodates a maximum number. For example, the first energy level accommodates 2 energy levels, accommodates 2 electrons, and the second energy levels, second and the third, accommodates 8 electrons. For example, we use the same sodium. Sodium has 11 protons, so it will be the first energy levels accommodates 2. So when you subtract 11 minus 2, we remain with 9. And the second energy levels accommodates 8. So the second one will be 8. When you add these 2, it will be 10. So 1 is remaining. The last energy level will accommodate 1. You can represent this using dots or crosses. Also, elements can be classified into metals or nonmetals. For example, some metals, it can be classified into metals, nonmetals, and metalloids. Some metals are magnesium, calcium, potassium, and some examples of nonmetals are oxygen, carbon, and some examples of metalloids are silicon and boron.